Okay, pull out your phone for a second. Seriously, open your weather app. That little number, 42, feels instant, like your phone just knows. But that forecast is the final stop in a global relay race. Radar sweeps, satellites in orbit, balloons launched around the world, ships in the middle of the ocean, and a whole lot of government-funded infrastructure like undersea cables and supercomputers. Today we're going to follow the data from all over the world until it lands on your phone as your weather forecast. And stick with me, because by the end of this video you'll understand why two different weather apps can show you two totally different forecasts, even at the same location. Alright. Start here. This big bubble is the thing we're all trying to predict, the weather. No vibes, no guesswork, the real atmosphere, moving, changing, messy, and completely untamed. And the only way to forecast it is to measure it a lot. First up, radar. This is our flashlight to see what's happening with the weather close to us, sending out microwave pulses and listening for what bounces back. It's how we track rain, snow, hail, and with Doppler capability, it can even show us the wind inside storms. Radar is the reason you can watch a storm march toward your town in near real time. If you'd like a crash course in how to interpret Doppler radar, drop a comment below and let me know. Next up, skywarn spotters. Because sometimes the most advanced sensor is a human being under the sky. The National Weather Service trains volunteer spotters to provide real-time observations that confirm what radar can't always prove from a distance, like tornadoes on the ground, hail size, flooding, and damaging winds. They turn "it looks bad" into "it is happening." Then we move offshore, ship observations. Out in the open ocean where there aren't many weather stations, ships become roaming sensors, measuring pressure, wind, temperature, sometimes wave conditions, and reporting that data back to land stations. This matters more than many of us realize, because so many big systems, fronts, cyclones, hurricanes, feed off of the ocean. And because storms in the mid-latitudes move from west to east, knowing what the weather is doing over the Pacific Ocean is critical to forecasting the weather across the United States. Next, weather balloons. These are the atmosphere's vertical scan. A balloon carries instruments upward through layers of air, measuring temperature, humidity, pressure, and wind with altitude. This is how we learn what the sky is doing above our heads. Because the steering currents that guide storms aren't at street level, they're up there. And weather balloons can sense the middle layers of the atmosphere that satellites can't see. Satellites are like cameras in space that provide us the big picture. Cloud patterns, moisture plumes, wildfire smoke, storm top temperatures, and the shape of entire weather systems. Satellites are why we can track storms before they ever touch land, and drives home the fact that meteorology is truly global. The atmosphere doesn't care about political borders. Commercial airline flights are basically mobile weather probes. As planes climb, descend, and cruise, they collect wind and temperature data along routes that cross continents and oceans. And here's the wild part. That data actually feeds the forecast that tells you what weather is coming later today. Now, we're back on the ground. Surface observations, weather stations, at airports, on mountaintops, and cities along highways report the basics: temperature, dew point, wind, pressure, and precipitation. This data is literally the ground truth that keeps everything honest. If the model says it's 72 degrees, but stations say it's 80 degrees, we've got a problem to solve. And then, buoys. These are the ocean's weather stations, measuring wind, pressure, sea surface temperature, and waves. They're critical for coastal forecasts and marine safety, but also for understanding how the ocean is fueling the atmosphere. And everything we just talked about can be described as data collection. All of these sources, radar, spotters, ships, balloons, satellites, aircraft, surface stations, buoys, are building a constant updating snapshot of the atmosphere. But a snapshot isn't a forecast yet. Like going to the doctor, measuring your vital signs and symptoms gives you a diagnosis, but then the doctor needs to give you a prognosis of how you may recover. In meteorology, this prognosis is the forecast. Now, watch the flow. These lines are the moment raw observations become something bigger. Data racing into the systems that can actually predict what comes next. This is where what is happening turns into what might happen. Here we've made it to the engine room. Computer models. This is numerical weather prediction, the atmosphere translated into calculus and physics equations, run forward in time on powerful supercomputers. Some of the world's most powerful supercomputers are dedicated to weather prediction. These models ingest the observations, reconcile contradictions, and build a 3D best guess of the atmosphere right now. Then, they push that best guess into the future, hours, days, and beyond. And when your forecast changes suddenly, a lot of the time it's because the next model run just got brand new data. So just like the food in your pantry, forecasts can get old and stale and routinely expire. This is why forecasts need to be continuously updated. The National Weather Service, or NWS, is the publicly funded backbone in the US. And if you live elsewhere, your country has its own version of a National Meteorological Service. Inside the NWS, you'll see two parts. First, the local weather forecast offices. These are the small teams of meteorologists focused on your region, issuing watches, warnings, and advisories for your local area. In addition to the local offices, there are the National Centers for Environmental Prediction. These handle the big picture guidance, major national scale forecasting specializing in different hazards like hurricanes, tornadoes, winter storms, flash flooding, river flooding, aviation weather, and space weather, just to name a few specialties. They also do coordination with the local offices to ensure that the whole system keeps running like a well-oiled machine. The National Weather Service is where computer model output meets expert interpretation, because the atmosphere doesn't always behave like the clean version in our equations. And then the part most people never think about, the fact that a huge chunk of this web of observational and forecasting infrastructure is funded publicly by the government. Meaning, whether you use a fancy weather app or not, you're often benefiting from data and systems built for the public good and paid for by taxpayers. That's not a conspiracy. It's the reason forecasts can exist at national scale, 24/7 for everyone. And these services cost you only $3 to $4 annually, with an estimated economic benefit of $100 billion. That's an insane return on investment. Now we drop into the private side, private company forecasts. Private companies take the same river of information, government observations, model output, public forecasts, and then they add their own layer, custom blending, specialized models, hyper-local tweaks, prettier graphics, and product-specific forecasts for different sectors like travel, sports, energy, and more. This is also why branding can be misleading. It might look like the company website or app is doing everything, but it's often building on a foundation that already exists and paid for by you and I through taxpayer-funded services. And here's the new player, AI models. These can learn patterns from massive historical datasets, sometimes speeding up forecasting or improving certain types of predictions. In the real world, you'll often see AI used alongside traditional models, as a boost, a shortcut, or a second opinion. Some AI models are being developed by private companies, while others are being developed by the government. Think of it like this. The atmosphere is still the atmosphere, but the tools for predicting it are evolving fast. In just a few months from now, new AI weather models are sure to hit the market. And now we arrive at what you actually interact with, your everyday front door to all this complexity. First, websites. This could be your favorite web page for weather, a satellite page, a forecast portal, something you check when you want details and context. Websites often pull from private forecast providers and sometimes directly from public agencies too. Next, news media, your local station, national broadcasts, online outlets. And notice those dashed lines feeding in? This is that extra pathway where public data can flow directly into what you see, even when it's packaged by media, because licensed broadcasters are legally required to broadcast watches, warnings, and advisories from the National Weather Service. Then, weather apps, the fastest, easiest way to get a forecast. Also, the most likely to hide the complexity, because an app might blend multiple models, adjust for your exact GPS location, update on a schedule, and smooth the forecast so it looks and feels nice. That's why one app says 30% and another says 70%. Not because one is lying, but because they're processing the same sky through different algorithms. And finally, there you are, the person holding the phone. Those colorful bands are the final delivery. Websites, news, apps, all pulling from private forecasts, public forecasts, computer models, and the raw observation network to give you that tiny icon and a number. So the next time you check the forecast, remember, you're not just seeing an app. You're seeing the output of a global, constantly updating system, built from sensors on land, sea, sky, and space, and powered in a big way by public infrastructure. And if any link in that web of data goes missing, the accuracy of your forecast will take a hit. If you want more breakdowns like this, storms, forecasting, and the science behind the wild skies above us, hit subscribe here on Untamed Skies, and drop a comment. Which weather app do you trust most, and has it ever burned you? Because in a future video, we'll dig into why forecasts sometimes bust, and what the atmosphere is doing when it outsmarts the models. Until then, keep looking up.